In this video for section 6.1, we're going to talk about something called the normal distribution. It's this bell-shaped symmetric distribution that we saw earlier when we talked about the empirical rule. Now we're giving it a formal name of the normal distribution. We use binomial distribution, which we talked about earlier, if we have discrete random variables. The word discrete means that the values can only be whole numbers. If we have a continuous random variable, then we use the normal distribution. And the word continuous means that it can take on any decimal or fraction value. It doesn't have to be a whole number. So in the normal distribution, the mean and median are in the center of the distribution. It's symmetric, and the probability of something being greater than the mean is 50%. The probability of something being less than the mean is also 50%. With the normal distribution, we could calculate the probability of getting exactly one number. And we can do this with discrete distributions. But with a continuous distribution, the probability of being exactly any particular number is 0. And this is a little bit strange to think about because obviously something is a particular number, but this actually makes calculations with the normal distribution a little bit easier. And we'll see why that is in a second. We also have what's called the standard normal distribution. Now this sounds like we're just repeating the same word here, but the standard normal distribution is a special normal distribution that has a mean of 0 and a standard deviation of 1. We're going to use Minitab to calculate probability values, just like we did with the binomial distribution problems. So you're going to want to pay attention to what you are given in the problem. If you are given a number of trials and probability, then it is a binomial distribution problem. If you're given mean and standard deviation, then it is a normal distribution problem. So let's look at example 6.1. Airport managers have found that the time needed to get passengers loaded onto an airplane is normally distributed, with a mean equal to 15 minutes and a standard deviation equal to 3.5 minutes. So as you see, they're giving us the mean of 15 and the standard deviation of 3.5. And the first question is asking us to find the probability that loading passengers will take 22 minutes or more. So we're going to use Minitab to calculate this probability. The book is going to show you some other methods. I would recommend not trying to use those, as using Minitab is going to be easier. So again, we're going to go to Graph and go to Probability Distribution Plot. We're going to select View Probability. And then now we can leave this on normal distribution because that's what we want to use. It's automatically going to fill in 0 for the mean and 1 for the standard deviation, or that standard normal deviation that we talked about earlier. I'm going to change my mean to 15 minutes and my standard deviation to 3.5 minutes. Now I need to click on Options. Now, when I look at the problem, it says, I want to find the probability that loading passengers will take 22 minutes or more. Now, unlike the binomial distribution, it doesn't matter if it's 22 minutes or more or greater than 22 minutes. It doesn't matter if that 22 is included or not. Either way, I'm going to use 22 as my x value. And that's because the probability of any individual value is 0, so I would get the same thing whether I included the exact value of 22 or not. So 22 minutes or more, and then the greater side of 22 is going to be a right tail. So I'm going to make sure that that is selected, and then click OK, and click OK again. Took a little bit of time there, but here's my graph. So again, we have our graph here. I can put the spreadsheet down because I don't need that. This graph is a smooth curve, unlike the binomial distribution where it was made of rectangles. And I can always check that I have the correct mean and standard deviation that I was given in my problem at the top. And then looking at the graph, I see that I have shaded everything from 22 and above. And so my answer is going to be above the graph, this 0.02275. I need to pay attention to how the homework wants me to round if I'm doing this in a homework problem. 4 digits after the decimal point, I would round this up to 0.0228. So if I'm going to write my answer, it would be 0.0228. Now the second question is 95% of flights will be loaded in less than what time? Now this is a different type of problem because this is a probability. And they want me to find the x value. The time here that they're asking for is an x value. So I'm going to go back to Minitab, and I'm going to do the calculation again, graph, probability distribution plot, and view probability. Now it's keeping my mean and standard deviation. I'm not changing those, but what I am changing is instead of a specified x value, I'm going to check a specified probability. And then I'm going to put the probability in the box that I want. And so my question is asking, 95% will be loaded in less than what time? So I want to find what time is below 95%. So I'm going to change the probability to 0.095 and select left tail because I want to shade the area below 95%. Then I will click OK. And here's my graph. Now notice that the 0.95 above the graph is shaded. That's telling me that 95% of the area is shaded, which is what I want. Now 95% isn't my answer this time. This time I find my answer by looking on the x-axis. 20.76 is my answer in this case. That's the time at which 95% of values would be below. So pay attention to, again, how the problem wants you to round. If it's maybe 1 or 2 digits after the decimal point, or it could be the nearest whole number. So if I want to round to 1 digit after the decimal point, that would be 20.8. And that is the time in minutes.